Okay, so this question here is an inflation problem. Most inflation problems we're going to be looking at are going to look at how much an amount of money is worth after putting it in the bank for a certain amount of time. Then we're going to look at how much it would be worth when it's inflated for those same amount of years. And then we use both of those values to find what the actual return on investment is. So part A, we're finding the future value of this initial investment of Max's. Part B, we're going to think about how much money Max would need in 5 years' time to pay for the same amount of $10,000. And then in part C, we're going to plug it back in and figure out what his actual savings or investment rate would be. As a rule of thumb, generally it's going to be somewhere in the vicinity of the savings rate take away the inflation, but it's not exact. We can't just take away 1.95 from 3.95. So let's look at the first part. We've got part A here. Max has $10,000 to invest. He's got a savings account that gives him 3.95% per annum, and it's paying monthly interest. So that's compounding monthly. He's saving for 5 years. And then our last sentence is not relevant to our first part, but it's telling us that inflation is averaging 1.95% per year during that time. So let's ignore that last sentence for the first part A. So Max has $10,000, so negative $10,000 is our present value. He's investing it in a 3.95% savings account, which is compounded monthly, and that interest also gets paid in monthly. He wants to save for 5 years. So 5 times by our PY, which gives us 60. We don't have a regular payment, and the future value is what we are chasing. So if we go into our compound interest on our calculator, 60, 3.95, negative 10,000, 0. We've got 0, and then 12 and 12. So we're going to come out with a future value of $12,179.58. What that tells us is that after the 5 years of it sitting in that bank account, this is the principal or the present value plus all the interest that he's earned. So he's earned about $2,000 interest, which is pretty good. When we look at part B, we've got this equation here, which is actually the compound interest equation, but we are sort of adapting it for the use of figuring out figuring out how much a certain amount of money is worth in 5 years' time. We kind of do it round the other way though, because we're more interested in figuring out what amount of money he's going to need in 10 years' time, which is worth what that 10,000 was back in the day. A little bit of a complex complex concept, but the main thing here is to ensure that we understand the process, and then we can start understanding what the values mean. So the FV is the indexed or the inflated value, is what we're trying to find in part B. The PV is the amount of money that he has to invest at the start, which is 10,000. We've got 1 plus I, where I is our inflation rate per year. So we've got 1.95%. So you could do 1.95 divided by 100, or you could just put it in like this if you understand doing it that way. And it's raised to the power of the number of years. Now, just a quick rundown of what this formula is actually doing. So we've got the $10,000, that's basically like our start value. After 1 year, it's being times by 1.0195. That's going to increase it by 1.95%. When we raise it to the power of 2, it does that twice. When we raise it to the power of 3 times, and so on. So basically it's showing us what happens after 5 years of this average rate. When we plug that into our calculator, we will find that we have 195. $11,013. $11,013.77. So what Max could buy for $10,000 5 years ago is now going to cost him $11,000. That's one of the more sort of base level understandings that we're hoping that you can utilize this for. So your money becomes worth less over time because they basically have more of it. More of it is printed, etc. So now we're going to compare this $12,179, this $11,013, and we're going to see what the actual real rate of return he would be getting on his investment, including the inflation. So there's a few things that we need to do. Once again, we're going to use our compound interest function on our calculator. Our N is just going to be the number of years, and our PY and CY we just set to 1. So because they're set to 1, our N doesn't change either. The interest rate is what we're trying to find because that's our real rate of return. You might see it written as RROR. We don't have a payment. Now we're starting with our new PV. So our new PV is the indexed amount. So negative $11,013.77. Basically what that's going to do is that's going to start us off thinking about how much that $10,000 would already be worth in the future. The FV is going to be our original FV because we're trying to see, we know that it's going to be a lower amount. So if we're starting off with this 11,000 and only going up to 12,000, we can see immediately that that's only an increase of about 1,000 compared to about 2,000 previously. So again, go into your graphics calculator, finance section, N is 5, interest rate we set to 0 because we don't know what it is. PV is $11,013.77. There is no PMT. We have $12,179.58. PY is 1, CY is 1. We click the interest and we get 2.03%. Now, as I said earlier, we generally are going to see that it is close to the savings rate or the compound interest rate subtracting the inflation because they are kind of battling each other out. But do keep in mind that it's not going to be exactly. But the main thing I want you to always do, if you for some reason came out with a real rate of return of something like 6% or even 4%, you would know that that's not right because it is more than the amount of interest that you got initially. So straight away, that should be a red flag. If you got a very low one, like say, 0.5 or even 1%, you might want to double check your calculations. With these questions, again, it's good to answer it with a brief sentence. So and you can use an abbreviation. The real rate of return on Max's investment is 2.03%.